Let's state the interval of positivity and interval of negativity, as well as interval of increase and decrease by sketching the function f of x is equal to negative 1/2 x minus 2 squared times x plus 4. Okay, so let's sketch this function first, and then we can look at when y is positive or negative, or when the function is positive or negative, and when the function is increasing or decreasing. Well, if we want to sketch this function, let's take a look at the leading term here. So the leading term is negative 1 times x squared, because this term is going to have the highest degree of 2, times x to the power 1, which is basically negative 1/2 x to the power 3. Okay, so this tells us a here is negative 1/2, so a is less than 0. So this also tells us that the degree here is 3. So then the maximum number of turns you would expect is 2, so you can have a minimum or a maximum point. And this implies that we have a negative odd degree function. Because we have a negative odd degree function, if we were looking at the end behaviors of the function, right, the end behaviors would be in quadrants 2 and quadrants 4. Okay, so we'd have quadrants 2 and quadrants 4, right? And after we figure that out, the next thing what we want to do here is let's find our intercepts, right? So let's start with our x-intercepts, right? So I'm going to let f of x equals 0, so negative 1/2 times x minus 2 squared times x plus 4 equals 0. So x can be equal to 2 and negative 4, right? You can also figure out your y-intercepts here. You know what, I'll just do it in the same color. Y-intercept, I'm going to do f of 0, which is going to give us negative 1/2, 0 minus 2 squared, 0 plus 4, which is negative 1/2, negative 2 squared times 4, so that's 4 times 4 is 16, times negative 1/2 is negative 8, right? So f of 0 is negative 8. Okay, so the point is 0 and negative 8. Now, after finding our x-intercepts, we also want to figure out the roots and the behavior of the roots, right? So if we want to find the behavior of the roots, right, so our roots here, our x-intercepts here are 2 and 0, and negative 4 and 0. We want to look at the order. The order of the 2 and 0 root is a 2. This order is a 1. So the behavior around these roots, right, this is going to pass through 2 and 0, but it's going to, oh shoot, sorry about that. It passes through the negative 4 and 0. It passes through the negative 4 and 0, but it's going to be concave to the 2 and 0. Does that make sense? So keep that in mind. So after we have our behavior of the roots, we have the intercepts and so forth, we have an idea of how many turns and what the end behaviors are. Let's sketch out this function. Okay, so I'm just going to create a general graph here. Actually, you know what, let's just do it here. Plenty of space here. Okay, so let's create a sketch here. Right, so it's a negative odd degree function. I'm going to plot the roots real quickly. So the roots here, there's going to be a 2 and a negative 4. Right, this is the 0 mark, so this is negative 4 and 0. This is 2 and 0. We have a y-intercept of 0, negative 8. Right, so you know, let's just put that here. I'm not drawing this to scale. Okay, let's say this is 0, negative 8, and we know that the end behaviors here, follow the trace, it's going to be concave to this point, and the end behavior should be in quadrants 2 and 4, right? So it should end off in this quadrant 4, so it should be concave down to 2 and 0. Okay, so let's say it ends off here, and as a result it should go there. It should loop through this. So this is a pretty good curve, I think. Okay, and then it should loop up. Right, once again guys, it's a sketch, right, not too important. However, we need to understand that there should be, right, 2 turns, and we should have a turn there as well as here. So that's good, right? So we do have 2 turns here, that's consistent, right? We don't actually have to find any other maximum or minimum points, because the maximum and minimum points are already listed on this graph, right? And because this is an odd degree function, we have a local maximum at 0 and at 2 and 0, sorry about that, and a local minimum. So there's a local maximum at 2 and 0, and there's a local minimum at 0 and -8. So keep that in mind. Okay. And you can see there's opposite end behaviors here, positive infinity, negative infinity. Now what we want to do here is we also want to look at intervals of positivity and negativity. Let's take a look at the intervals of positivity. That's basically when f of x is greater than or equal to 0, when it's positive, right? So when it's greater than or equal to 0, we're basically looking at anything above the x-axis, right? And the only point in which that's going to occur is basically when x belongs to negative infinity as well to -4. Okay, so this is an interval of positivity when it's positive. For the remainder, right, so the interval of negativity here, when f of x is less than 0, x will basically belong to -4 and positive infinity, not inclusive of -4. Okay, so that's the interval of positivity, interval of negativity, which you can see out here, right? It's all of this basically, right? So we understand that. Next thing we want to look at is interval of increase, interval of decrease. Okay, let's take a look at the interval of increase. Okay, so interval of increase, you're going to have a positive slope. So if we're looking at a positive slope, you know what, I should do interval of increase in orange, so that way we can kind of... Okay, so this is your interval of increase, and you can notice that you have a positive slope from this point onwards, right? So from 0, x belongs to 0 and 2, in between that, right? So we're just looking at not when the slope is 0. And the other intervals, let's say this is interval of decrease. Okay, so we have an interval of decrease, and that occurs here all the way to 0, right? So x belongs to 0, whoops, made a mistake again, negative infinity and 0, as well as 2 to positive infinity, right? So union 2 and positive infinity. So those are the two intervals where you see an interval of decrease. So those are our two intervals that we wanted to look at: interval of positivity, negativity, and the decrease and increase, right? And it becomes very straightforward once you get all these characteristics down and you sketch the function.